So now that we've gone through an introduction to Kc, on how to figure out the Kc expression, also be able to figure out the value for that Kc expression as well. Let's go into a little bit more into equilibrium types. Being able to have something that's homogeneous and heterogeneous, and also dealing with pressure as well. So let's deal with pressure first. So instead of concentration, if you have pressure, you're going to represent the K as Kp in this case. Oops. So you have Kp in this case. Now Kp is going to be determined in the same manner as Kc. So you would do the Kp expression out same exact way as the Kc, and also if they give you pressures within the problem, you can figure out your Kp just like you did with the Kc before. Now, some problems though, you'll actually be given the Kc, and then they'll want the Kp from that. You can figure that out by using the following equation, right there, where Kp is equal to the Kc times R, which R is the 0.0821 that you were using before, T is just temperature, and delta N is just the change in number of moles. So final number of moles minus the initial number of moles. So let's go through how you would determine something like this, where here's an example. I give you temperature, I give you the Kc of this reaction, you need to find Kp. So if you were to take that equation that I gave you previously, Kp equals Kc, so 3.92, times R, so your R is just 0.0821, times the temperature, make sure it's in Kelvin, so 25 plus 273, so that would be 298. And then that is all to the delta N power, which again, delta N is just basically the final number of moles minus the initial number of moles, which we can get by looking at the coefficients within our reaction. So in this case, again, if you don't see a coefficient there, it's just a 1. In this case, if we look at our products, we see that we have a 1 here and a 1 here, so you have a total of 2. So that would be 2 minus, and then if you look on the other side, you have a 1 and you have a 3, so that's 4. So you have 2 minus 4 for your power in that case, which just becomes a negative 2. So you basically have 0.0821 times 298, and that is all to the negative second power. So if you were to rewrite this, this is what it would look like. Oops. To the negative second power, like that. So just go out, multiply those two first, then go to the negative second power, then multiply it by the 3.92, and after you do all that, you should end up with a Kp of 0.0065. Here's another example. In this case, again, I give you the Kc, which is 0.00326 in this case, and I also give you a temperature, 191. You need to find the Kp. So let's go through. Kp equals Kc, so 0.00326, times your R, so 0.0821, times the temperature, make sure it's in Kelvin, so it would be 464. And that is all to the delta N power, which if we come up here, we notice that we have 1 and 1 on our product side, so that's 2, and that's going to be minus a 1 on the reactant side. So basically this is all going to a power of 1. So it's all going to end up being 0.00326 times 0.0821 times 464. So if you do that out, you should end up with a Kp of 0.124. So that's just one way of being able to find Kp if you're given the Kc of a reaction. Now let's just go into different types of equilibrium. A homogeneous equilibrium is just basically that equilibrium where you have reactants and products in the same phase, meaning they're all liquids, they're all solids, they're all concentrations, they're all, pressures. So everything's the same for homogeneous. For heterogeneous, you have reactants and products at different phases. So you might have a liquid, you might have a gas, you might have a pressure, that type of thing. Now, when you're dealing with your Kc expression or your Kp expression, whatever it is that it's asking for, you're not going to put in liquids and solids because those aren't affected by equilibrium. So if you see something that's a liquid or a solid, you don't put it into the expression. So for example, in this case, we have this equation, and we're looking for the Kc expression. So you have the Kc, products up top, reactants on the bottom, same thing as before. But in this case, if we look, we have CaO, it's a solid. Because it's a solid, we're not putting it in the Kc expression. Then we have CO2, which is a gas. That one we can put into the Kc expression. So we put it like that. Now that should be over our reactants, but if we look over here, CaCO3 is a solid, and equilibrium isn't affected by a solid. Solids aren't affected by equilibrium, so you're not going to put it into the expression. So this right here is your overall expression. And then one last example, you have your equation right here. You're looking for the Kc expression. So that's equal to the products, which H2O on the product side is a gas, so that you can have in, because gases are affected by equilibrium. And then that should be over the reactants, but H2O on the reactant side is a liquid. Those aren't affected, so you don't put it in. So here is what your expression should look like.